This set of notes is Chapter 3, Section 2, the string class. Continuing in Chapter 3, we will focus on the services of the string class. Now, the string class that you worked with in C++ is fairly similar to the Java string class. But once a string has been created, neither its value nor its length can be changed. Therefore, the string class is often referred to as immutable. However, several methods of the string class return new string objects that are modified versions of the original, and we can always invoke the constructor to create a new string object that will replace the one we were working with. We're going to see some examples in code in just a few minutes. Some other features of the string class is that it will allow us to individually select the characters from our string. So if we want to refer to a particular character within a string, we can do that by specifying its index. Just like C++, Java starts counting from 0. So when we're talking about the characters in a string, we start numbering them from 0. So in the string hello, H-E-L-L-O, the first character H is actually stored in index 0, and the O is stored at index 4. The length of this string would be 5. So the character indexes range from 0 to the length -1. Here are some other methods from the string class. We're not going to be looking at all of these, but as part of Project 1, you are asked to explore the string class library. You will go and find out about 3 different methods available in the string class and write a little report about those various methods and with sample code to show how you could use them in a program. Let's take a look at the sample listing from your textbook 3.1. I brought this program into the Java environment so that we could look at it more carefully and watch it run. Let's look at the lines of code. First, we see string phrase, sect2, change is inevitable. Then there are mutations 1, mutation 2, mutation 3, and mutation 4 declared. Recall that when we declare, we just identify the type and a name for our object. The next system out print line displays the original string phrase. And then it shows the length of the string by calling its length method. The length method actually returns an integer value. Because all the input and output in Java is done as strings, we concatenate a string representation of that integer to length of string and then display it. We see mutation 1 concatenates the phrase except from vending machines. Mutation 2, starting with mutation 1, change is inevitable, changes all of the characters to uppercase and stores that in mutation 2. So this method of the string class, to uppercase, is quite similar to the C++ string method, to upper. Mutation 3 replaces all occurrences of capital E with capital X. Now that will work on mutation 2 since we just created an uppercase example of the string. Mutation 4 uses mutation 3 and draws from it a substring of the original. Now we're going to look at this very carefully because the substring works in a surprising way. Then we print each one of these out And I'm going to add one other line here that shows, even though they're immutable, we can change them by declaring a new string. So here at the bottom, I'm going to set the phrase to, wait a minute, I just changed this string. And now I will print out the changed phrase. And its length. By copying those two original lines of code at the top of the program. Let's run it. Original string, change is inevitable. The length of the string is 20. Mutation 1 prints out change is inevitable except from vending machines because we concatenated except from vending machines onto phrase. Mutation 2 uppercases the entire phrase of mutation 1. Mutation 3 changes all the E's found in the string to capital X's. And mutation 4 is the substring from 30 through 29. So look at that carefully. If we start counting from 0, C, H, A correspond to 0, 1, 2. Then character N is the third character. And we display through character 29. So that's a little bit of a surprise with that substring. It shows us one past the actual character that we end with. So 3 is the first character index, and the second character index there is actually one past the characters that we retrieve from the substring. You have to be careful with that one. It's a little bit of a surprise. Finally, I did change phrase. Now wait a minute. We said it was immutable and I just changed it. So how did I do that? Well, recall that we don't have to write new string with our strings, but that's what happened here. And I allocated a new string. Wait a minute, I just changed this string. So I did not overwrite the memory location of change is inevitable. Instead, I went and got new memory location and stored the new string in that new object, and that's what we're looking at. So there is no way for me to directly make a change to the original change is inevitable, but I can replace it, and that's what I did. I replaced it with a new string object. I hope this helps you understand strings more thoroughly. Please play around with the programs in the book. One other note, after this week, we will no longer be using programs of this style. So I don't want you to get too comfortable with having main methods that have all of the code, because that is really not a good object-oriented style of programming. We're just using that to demonstrate some features. Our next programming example will be more realistic and the way I will be asking you to code your projects from now on, where there's minimal amount of code in the main and the work is done by actual class objects.